Hey everyone, welcome to another interesting episode of the math class where today we are going to take another interesting topic in this domain of mathematics, which is none other than calculus. The idea to create today's video arose when I saw a lot of suggestions from you folks when you visited my previous videos, and then you suggested me to create this topic on calculus for the novice beginner, right? Somebody who is not familiar with this topic already and wants to gain advantage by understanding what calculus is, then this video is for you. So without wasting further time, let's delve into what this calculus is all about. And by the end of this video, I'm sure that you'll be able to familiarize yourself with the basic fundamentals of this branch of mathematics called calculus, right? So let's take a whiteboard and try to understand what fundamental problems is calculus basically trying to address. So there are two problems which calculus is trying to address. The first one is the instantaneous rate of change. All right, that's the first problem. And the second problem is the accumulation, right? So basically, calculus is called as the math of change, right? So let's see what change are we exactly talking about. Let's look at the first problem, right? The instantaneous rate of change. So that's basically, in other words, it's called as differentiation. Let's try to understand what this is all about. Let's say we have a curve that looks like this. We have a plot that looks like this, which is basically the time t versus the distance s covered by a car. All right, there's a car which is traveling to a particular location, and then it starts at time t is equal to 0, right, and begins its journey. So at times t is equal to t1, it has its own distance. At times t is equal to t2, it has its own distance, like this, t3, t4, t5. Let's say the curve something looks like this. All right, curve somehow looks like this, right? So now suppose you want to answer the question that what is the speed of the car from this time interval, right, to this time interval, right? From this time, like t equals ta to t equals tb. What has been the speed of the car from this time? So it's nothing else but the total distance covered divided by total time taken, right? So let's say the total distance covered is nothing else but it's like, say, SB, right? So at t is equals TB, the distance is SB, right? And then at t equals TA, the distance is SA. So the distance between this interval is nothing else but it's given by SB minus SA, right? The time is TB minus TA. Now suppose you wanted to compute the distance between, like, say, not the distance between, but then the distance, the rate of change, like, say, the velocity, right? So this is the speed, right? This is essentially the speed, maybe the velocity in vector terms. So suppose you wanted to know the velocity only at a particular point, like, say, TC, right? So how do you know that? So there's an idea, there's a trick for doing this, and that's exactly what calculus does for you, right? What it does is it basically tries to reduce this gap between TB and TA such that this value TB minus TA, or you can say it's delta T, that tends to 0, right? If that tends to 0, then this earlier computation, which was like SB minus SA, which is this distance, right? SB minus SA divided by this distance, right? TB minus TA. So at this moment, it looks like, say, a triangle, right? Right triangle. So this is SB minus SA, this is TB minus TA, right? So if you keep on reducing this gap between TB and TA, right? So this is TB, TA. Now, if you reduce this further, right? So much that this TB minus TA tends to zero. So SB minus SA would also tend to zero, right? Right? And then this triangle would slowly keep on reducing until it becomes a point, right? It's not exactly zero, but it tends to zero. It's called as a limit in mathematics, limit of something tending to zero. And this representation is basically given by, so instead of your initial SB minus SA, which was like delta S, and then TB minus TA was delta T, right? As this delta T tends to zero, this is represented as ds by dt, which is the instantaneous rate of change at a particular point, like say TC, right? Whereas TC is nothing else but it's like TB minus TA, where this difference tends to zero. It's so small that it's approaching zero, but not exactly zero. That's basically the approximation called as calculus. It's called as an infinitesimal. What is infinitesimal? This dt is basically an infinitesimal because it tends to zero, but it's not exactly zero, but it's very small. Think about it like suppose you have a large rod given to you. You divide the rod into two pieces, and further this thing you divide into two pieces. Further this thing you divide into two pieces, and further this thing again divide into two pieces. You keep on dividing it into two pieces such that you reach a point where you keep on dividing it, and now you can't further divide that. But then this limit is infinite, right? You can just keep on dividing it over and over without stopping, right? Until it approaches a conceptual case of a dt, which is you can consider it to be almost like zero, but not actually zero, right? So that's given by, so in the language of calculus and differentiation, so the science of calculus enables you to determine this ds by dt, which is the instantaneous velocity, right? At a particular point. That's the first problem calculus solves. And the second problem is, so like there are various functions, like suppose your curve, it looks like uh, x versus cos of x, right? That will look something like this. So at this point, what is the derivative d by dx of cos of x? So it basically tries to address what is the rate of change of this function at this point, right? That's what it's trying to address. Clear? So a derivative at a point is nothing else but is the slope of the tangent at a particular point. Clear? So like a derivative at this point is nothing else but the slope of the tangent at this point. All right? Then the second problem which calculus tries to solve is the accumulation under the curve. Right? So what is this basically? Let's draw again a curve for like say this time it's a velocity versus time, right? So let's say a curve looks like this, where this point, like any point of the curve, represents the velocity of your car at a particular time, say t1, velocity at say time t2, right? Now, if you want to know the total distance traversed by this car from beginning to the end, right? You basically need to know the individual distances covered at every infinitesimal intervals of time, right? Like say, let's take this small rectangle over here, right? Let's assume that this width of this rectangle is like almost dt, which is like something tends to zero, right? dt, where the width tends to zero, so it's called as dt. Let's say the width of this rectangle is so small, and then the height of this rectangle is basically the velocity here, right? So the area of this rectangle becomes, let's say this velocity is v1. So this becomes v1 dt. v1 multiplied by dt, right? Distance multiplied by the width, which is the time. Similarly, then let's take another rectangle. Let's assume that this curve, the area under this curve is made up of many such rectangles where the width of each rectangle is dt and the height is the velocity at that particular point. Now, if you add all these areas of each of these individual rectangles, right? Like say v1 dt plus say v2 dt plus v3 dt, what you get is the total area under this curve, which is nothing else but that's going to represent the total distance traveled by your car within this time interval, right? So this branch of calculus is called as integration and is represented as like the integration of velocity multiplied by dt, right? That gives you the distance, right? There are two types of integrations, like definite and indefinite. We can cover that later, maybe in later videos, but then this video is more for understanding the concept. So I hope the concept is clear, right? Like say if you add up these rectangles, right? Or maybe even if you look at it in this way, like if you add the lengths of say this line, this line, this line, this line, this line, this line, all the individual lines accommodated beneath this curve, if you add the lengths of all these lines, even that gives you the total area under the curve, right? And that represents the total distance traversed. So integration basically enables you to do that. So like suppose you have a curve, like say, just again, like say x and cos of x, which looks something like this. So integration, like say between 0 to this point, right? That would give you the area under the cos curve, right? So this will be, I think, pi by 2 in radians, or maybe 90 degrees, right? So another interpretation is that integration is also the reverse of differentiation, if you look at it, right? So like the derivative of distance with respect to time is like velocity, but then the integration of velocity and time is the distance for obvious reasons, right? Clear. So this is a small overview on calculus. I would be happy to create another video on how do you compute the derivatives of various functions, various commonly used functions like a quadratic function or maybe a sinusoidal function or maybe a cosine function. We can take that in later videos. But I hope this video was helpful. So uh, stay tuned for more such videos and then give the channel a like, share, and subscribe. All right? Thank you so much. Great day. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.